5 marks question repeated previous years. Now we will see the first topic, introduction we will see. Here we are designing passive components. Here which one we are designing? We are designing passive circuit component. These passive circuit components are very, very important for microwave frequencies. Passive circuits are very important for microwave frequencies. For these passive components, we are using one of the topic called directional couplers, hybrid rings, circulators, and terminators. These force is used for what purpose? For passive components, which it is used in microwave frequencies. First, we will see directional couplers. This directional coupler is a passive 4-port device. Here we have 4 ports. The 4 ports are port 1, port 2, port 3, port 4. These passive components, the first one we have directional coupler. In directional coupler, we have 4 ports, port 1, port 2, port 3, port 4. To these 4 ports, I am using 2 waveguides. One is primary waveguide, other one is secondary waveguide. Here, which is primary? The first sleeping line, upper side. This is primary waveguide. And second down part we have. This is secondary waveguide. 2 waveguides we have, primary, secondary waveguide. These 2 waveguides are connected with what? One line. Just cross-check this. This is connected with a common wall. This is connected with common wall, which is given in the second paragraph. What is given in the first paragraph? It consists of a primary waveguide, secondary waveguide. 2 waveguides we have, which is represented in the figure number 6.1. Next, a directional coupler consists of how many waveguides? 2 waveguides. 2 waveguides. First one is taking, first this line is taking as a primary waveguide. Second line is taking as a secondary waveguide. These 2 are connected with a common wall. This is the description of the diagram. Next, in the figure number 6.2, having 2-hole directional coupler. What is this 2-hole directional coupler? First line, I have one waveguide. Down I waveguide. In between, a gap is there. Like this. One waveguide, another waveguide, but in between, gap is there. When the line is transmitting, it will not go directly. It will enter into this one. While entering into this one, whether it is moving in this direction or it is moving backward direction, we will concentrate. Based on this, we will categorize this as a 4 parts. First one is PI. PI is incident wave. Here port 1 is PI is incident wave. Incident power at port 1. What is PR? What is PR? PI is incident. PR is the received power. Power it is received. Next, what is PB? Coupler power in backward direction. Why we are getting backward direction? When there is a split between the 2 waveguides, after coming it to the down, whether it will move in backward direction or in the forward direction. The backward direction is represented with PB. Forward direction is represented with PF. And these is expressed using 2 parameters. The first parameter is coupling capacitor C, and the second parameter is represented as directivity D. And we have formulas for this one. The coupling capacitor formula is 10 log Pi by P of base 10. What is Pi here? Incident power. PF is received power. Forward power. Here PF is forward power. Same way directivity is also calculated. What is the formula of directivity? 10 log base 10 PF by PB. You have to write this one. Actually, the backward power PB is equal to 0. The backward power PB equal to 0. After writing these 2 formulas, I have to give a conclusion. What is the conclusion here? PA is coupled. PA is Enter. PR is out. Backward, forward. Okay. And actually, what is these values in range? In general, the practical value of directional coupler is from 30 to 35 decibels. Its value is from 30 to 35. Again, in this, we have two types. First one is two-hole directional coupler, and another one is scattering matrix of the directional coupler. First, we will see two-hole directional coupler. In two-hole directional coupler, just observe the diagram. We will go for it. Same way here also we have two waveguides. Primary waveguide, secondary waveguide. There is a slit in the middle. There is a slit in the middle. Whatever the wave is coming, it is coming downward. Whether it is moving forward direction or backward direction, we will cross check. The distance between the slit is lambda g by 4. The distance between the, what is the distance between the slit is lambda g by 4. Now we will see here introduction for this one. A two-hole directional coupler consists of how many waveguides? Two rectangular waveguides coupled by two apertures. Here the space between the two waveguides is lambda g by 4. Where what is lambda g? Lambda is the guide wavelength. G means guide. Lambda is wavelength, guided wavelength. And from the diagram, how many ports is here? 4 ports, port 1, port 2, port 3, port 4. And wave is traveling like this. Just observe the figure. Wave is traveling this, but it is not going in straight direction. Why it is not going straight direction? Because there is a slit. As there is a slit, it is like going like this. It is open, so coming down. After coming down, whether it is will go in backward direction or in forward direction. Now we will see that one. What is the information is given here? Traveling waves propagating in directional coupler is shown in the figure 6.3. A fraction of a wave energy incidenting at port 1 passes through the holes and radiated into the secondary waveguide. Why it is radiating into the secondary waveguide? Because there is a split. So, as the holes, here these hole split acts as a which antenna? Slot antenna. This acts as a slot antenna. The forward waves in the secondary waveguide, if it is passes towards the port 4, if it is passing towards the port 4, or it is coming backward, Suppose it is passing towards the port 4, at that time port 3 is 0. Suppose it is passing backward direction, at that time port 4 is 0. The wave it is coming down, either going this side or this side. If this goes towards port 3, port 4 is 0. If it is going towards the port 4, port 3 side equal to 0. This is about which one? This is about two-hole directional coupler. Next, we will see scattering matrix S of the directional coupler. In scattering matrix X of the directional coupler, I am taking 4 by 4 matrix. How we will write 4 by X of Ij? I is 1, J is. Okay, here channel. First port, suppose I will write this S12. First port, second line. If it is S32, third port, second line. Like this, we will consider. Based on this, I am writing 4 by 4 matrix. Now, what is the 4 by 4 matrix here? S11, S12, S13, S14. Now, next, S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, S44. Here I am considering diagonal as a 0. S11, S12, S11, S21, S23, S24. S11, S22, S33, S4 keeping as a 0. And I'm concentrating few symmetric properties. What is the symmetric properties here? S of Ij equal to S of Ji. What it means? If I am taking 1, 2, 1, 2 equal to 2, 1. If I am taking 3, 1 equal to 1, 3. If I take 1, 4, 1, 4 equal to 4, 1. Like I am concentrating few symmetric properties, and there is no direct connection from what? See from the figure. Is any direct connection from 1 to 3? No, there is no direct connection from 1 to 3, as well as there is no direct connection from 2 to 4. So what I am doing, 1 to 3, 0. I am concentrating it down because there is no direct connection. Down. No direct connection. S13 equal to S31. S24 equal to S42, all making all these equal to 0. And I'm 6.4 conditions, 6.5 conditions, 6.6 conditions. I'm substituting in the 6.3 equation matrix. After substituting in the matrix, we will get one format. After substituting, we are getting 6.7. To this 6.7, what I am doing? Taking complex conjugate form. Complex conjugate means star I am choosing here. Star. This is original matrix. This is the original matrix to its complex form equal to identity matrix. Next, to this, what I am doing, I am following few conditions. The conditions is first one, multiply row 1, column 1. Second condition I am choosing, multiply row 2, matrix multiplication. Row 2, column 2. Next condition I am choosing, multiply row 3, column 3. Next, multiply row 1, column C3. These four multiplication, one row and one column I am multiplying. Check the first one. I will show one example line remaining the same procedure. 0 into 0, 0. S12, S12 star. Matrix multiplication. Next, 0 into 0. Next, S14, S14 star equal to 2. First line identity matrix. First line is what? Identity matrix. Understood first one? R1, C1 is completed. Next, R2, C2. Next, R2, C2. What is R2 line? What is C2 line here? Here, R2 is S12, 0, S23, 0. S12, 0, S23, 0. This is R2 line. What is C2 line? S12 star, 0, S23 star, 0. Now we will multiply this one. What you will get? S12, S12 star, 0 into 0, S23, S23 star, 0 into 0 equal to identity matrix 1. Which one is this one? R2, C2. R2, C2. And next multiply which one? R3, C3. Next multiplication is R3, C3. What is R3? 0, S23, 0, S34. What is C3? 0, S23 star, 0, S34 star. Again, these two multiplication we have to do. What is these two multiplications? 0 into 0, first one. Screen share. I'll share again. Screen. Next, what we have to do? R3C3. Next, R3C3. What is R3 line here? 0, S23, 0, S34. What is C3 line? 0, S23 star, 0, S34. Multiply this one. Next, R4. Last one is R1C3 you have to do. What is R1C3? Which is equation 6.12. Here this one is R1C3. Cross check R1C3. R1C3 satisfied. 4 equations we got. Is it? To this from 6.9. How I got 6.9? R1C1 we got now. In this S11 square modulus I am keeping. Modulus. Plus S14 into S14. S. Next S14 modulus of S14 square. That is 6.9 we got. And next 6.10 cross check how we got 6.10 from the above equation R2C2. S12, S12, S12 square, S23, S23, S23 square. And next check 6.11. Same squares we did. From equation 6.9 and 6.10. Just cross check 6.9 and 6.10. In 6.9 and 6.10, S12, S12 is there. So what I am doing, equating and I am making S14 square equal to S23 square. So S14 equal to S23. We got 1. That is 6.13. And next check 6.10, 6.11. 6.10, 6.11. Which is common? 2, 3, 2, 3 common. This is cancelled. Which is left? 1, 2 equal to 3, 4 is left. That is 6.14. And next, here, I'm imagining real terms and imaginary terms. Means I'm writing answer in terms of P's and Q's. For that, what I am doing? S12 equal to S34 treat as P. Wherever in this S12, S34 you are observing, in that place keep as P. Next, another condition. So, from equation 6.12, what we have 6.12? In 6.12, S12 equal to S34, is it? S12 equal to S34 we got. S12 equal to S34. In that place, I am making common. What is left? S23 is left to this side. S14 left to this side. This is made common. And I am treating that as P is not equal to 0, S23 equal to S14. S23 equal to minus S14 equal to minus 213. In these 3 places, we have to insert P. In these 3 places, we have to insert P. After this, real term is over. Now I am concentrating on imaginary term. Which imaginary term I will choose? S23, S14. I am treating it as what? JQ. S23, S14 is treated as JQ and substitutes all these factors in the matrix. After substituting the matrix, we are getting the matrix in terms of real terms P and in terms of imaginary terms JQ. This is about which topic? This is about scattering matrix of directional coupler. We will recall once again. I am taking 4x4 matrix. What we did in this? Taking 4x4 matrix. Diagonal terms is treating as a 0. And symmetry. What is symmetry? S of ij equal to S of ji. Those all terms I am making as a equal, and remaining there is no connection from 1 to 3 and no connection from 2 to 4. So those terms I said 0. Substituted all these terms in the matrix and we got one matrix. To this matrix, I am making complex conjugate and equivalent to which one? Identity matrix. And make to this R1C1. After complex conjugate, they make R1C1, R2C2, R3C3, R1C3. And form a final matrix. This is the final matrix in terms of P and Q. This is about directional coupler. Next topic, we have hybrid rings. Now we will see what is hybrid rings. In hybrid rings, I am taking 4. Very, very important short question can be considered. Here I am taking 4 ports. The gap between port 1 to port 2 is lambda g by 4. The gap between each port is lambda g by 4. Port 1 to port 2, port 2 to port 3, port 3 to port 4, port 4 to port 1. Like this, it is connected as a hybrid ring. Now we will see the description of this one. The 4 arms of the hybrid ring are connected in the form of a ring. The characteristics of hybrid ring is similar to hybrid tree. Now we will see its working. When a wave is incidenting on a port 1, input, where it will exit? Port 2. I am giving input at port 1. It will be exited at port 2. Now I am taking input at port 2. It will exit at port 3. If I give input at port 3, it will exit across port 4. If I give input across port 4, it will exit across port 1. And now we will see what is given here. When a wave incidenting in port 1, it splits into 2. Either it is moving thisward direction or backward direction. It is splitting into 2 and travel both the waves in opposite direction. One is in clockwise direction, another one is in anti-clockwise direction. The 2 ports reach at port 2 and port 4 are in phase. 2 and 4 is in phase. Port 3 is out of phase. Next, the same way. When the input is going at port 2, input is going at port 2. 3 and 1 is in phase, 4 is out of phase. Just giving the description and writing final matrix. Writing final matrix format. This is about hybrid ring. What is final conclusion of hybrid ring? 4 ports are connected in a ring manner, each with a difference of lambda g by 4. When a wave is splitting, either it will go in backward direction or forward direction. We have to concentrate in this. Next topic is terminations. Why we will use these terminations? Terminations are used for measuring impedance. Impedance means Z. Terminations is used to measure the impedance. Here, impedance is treated with Z, or else it is used to measure S parameters of the circuit element. Which parameters? S parameters of the circuit elements. It is used in measuring the impedance or to measure the S parameters of the microwave elements. It is of 2 types. What is the first one? First one is a matched load. Second one is adjustable short circuit. What is the function of match load here? Match load absorbs all the incident power and it is equivalent to the terminating line with characteristics. It is absorbing all the power. So which we can treat as one of the characteristics of the impedance. It is not wasting anything. It is absorbing all the input power. So this is one of the characteristics of the impedance. Now what is the second one? Adjustable short circuit, which is given in the 3rd paragraph. Adjustable short circuit provides variable reactance in the waveguide. It is made up of good conductors. These adjustable short circuits are made with good conductors. What are the things we can treat it as a good conductors? copper is treated as a good conductor, which is used in the waveguides to fit the waves. What about this second paragraph? This second paragraph is again explaining about matched load only. What is explained here? A slab or a lossy material is inserted in the waveguide. Termination meaning break. In between two, I'm inserting one slab. It will disturb, is it? That is treated as a termination. This is about termination. Maybe 2000, this one is repeated in 2023 as a short question. Explain about termination. 2023 లో ఎందులో వచ్చిందమ్మా షార్ట్ క్వశ్చన్ లో వచ్చింది. Now we will see the model questions related. What is directional coupler means? What we have to write definition of directional coupler, which is in the page number 60. First introduction we have to give. Next, explain the working of directional coupler with the block diagram. With the block diagram అంటే ఏది రాయాలి? ఇది. సెకండ్ ఆన్సర్ మొత్తం ఎక్స్ప్లెయిన్ చేయాలి. ఎక్కడి వరకు? టూ ఫార్ములాస్ కప్లర్ అండ్ డైరెక్టివిటీ వరకు రాయాలి. కప్లర్ అండ్ డైరెక్టివిటీ వరకు. థర్డ్ లో ఏమడిగారు? డిఫైన్ కప్లింగ్ ఫ్యాక్టర్ డైరెక్టివిటీ. ఓన్లీ డెఫినేషన్స్ ఫార్ములాస్. నెక్స్ట్ ఫోర్త్ క్వశ్చన్ ఏముంది? డిస్కస్ అబౌట్ టూ హోల్ డైరెక్షనల్ కప్లర్. ఇప్పుడు టూ హోల్ డైరెక్షనల్ కప్లర్ అంటే 6.2.1. టూ వేవ్ గైడ్స్ మధ్యలో బ్రేక్ వచ్చేసింది. ఐదర్ ఇట్ ఈస్ ఫార్వర్డ్ డైరెక్షన్ ఆర్ backward direction it is moving. And next, derive expression for scattering matrix of directional coupler, which is 6.2.2. Complete matrix derivation up to S. Now, what is the next question? Describe the construction and working of hybrid ring and write its S matrix formula. Write it its matrix. Next question is discuss about termination. What is termination? There are two types of terminations where we will use this termination. One is matched load, another one is adjustable short circuit. This is about block 3, chapter 6. Next we will see block 3, chapter 7, which we can guess one important essay question from this chapters. Unit 7. Unit 7 lo 3 topics ఉంటాయి. In the exam they will ask whether explain about Faraday rotation or explain about gyrator, explain about isolator, or explain about circulator. This is very, very important essay question from this block 3. From block 3. Now we will see unit 7 in block 3. Block 3. Now we are seeing unit 7. What are the topics we have here? Phase shifter, in the rotatory phase shifter. Next 7.3 is Faraday rotation and its application. In this we have gyrator, isolator, circulator. Now we will see this one. Introduction. In what is given in introduction? What is the meaning of phase shifter? Phase shifter will produce a phase angle between input line and output. Between input and output, we will get the phase, whether it is in phase or out of phase. It will produce a variable phase angle between input and output devices. This is one of the important point. Variable phase angle between the input and output. Maybe this phase is 0 degrees or 180 degrees, which we will see in the further. Next, in this, I'm in the, this suppose input sides to another side. In the middle, I'm using ferrite material. From input to output, I'm using ferrite material. Which type of ferrite material it is? This one is from input to output side, I'm using ferrite material. Is used in the development of devices in microwave frequencies. This ferrite material, whatever we are using, it is non-metallic ceramic type material we are using. Which type of material? Non-metallic ceramic type of material is used. And it having higher resistivity. What is its resistivity? Is in the order of 10 to the power of 14. Means very high resistivity. 10 to the power of 14, which it is compared with the dielectric constant. Dielectric constant compared to that one. So, what is the formula? I said we are using ferrite material. What is the formula of the ferrite material we are using? MO Fe2O3. Here M is any one of the divalent metal. Me is divalent metal, such as either in place of M we can use iron material or zinc material or cadmium material or manganese we can use in this place. The examples are in metal oxide. In place of metal oxide, I am using Mn, magnesium Fe2O3, ferrite. Another option, we have zinc ferrites. Like this, the final conclusion is from input to output. In the middle, I am using ferrite material. The formula of ferrite material is MO Fe2O3. Like examples is Mn Fe2O3, another one is Zn Fe2O3 we are using. Now this is working on the principle of Faraday rotation. So we will call as Faraday rotation. So this input to output aperture or the setup. In the middle, what I have? Magnetic field. To this one, I am applying some external magnetic field. What we are doing? We are applying external magnetic field, a strong external magnetic field. The magnetic field, whatever we are applying, it is very strong. Strong magnetic field is applied. So this applying strong magnetic field to the ferrite material. Definition. What is Faraday rotation? Applying strong magnetic field to the ferrite material is known as Faraday rotation. And this is about the introduction. In introduction, what is given? What is the definition? Which type of material we are using? What is Faraday rotation? Next, we will see phase shifters. Phase shifter means changing of phase. Changing of phase is called as phase shifter from input to output. First, we will discuss about the diagram. One side I have rectangular waveguide. Which waveguide? Rectangle shape waveguide. Rectangle means box-like edges. Okay. The two edges are like box shape. So in port 1 to port 2, the two output edges are in which shape? Box shape. That is rectangular waveguides. To this rectangular waveguides, beginning of the ends, I am attaching quarter wave plates. Which wave plates? Quarter wave plate. How many quarter wave plates we have in this diagram? Two quarter plates is there. In between two quarter wave plates, I am connecting another wave plate is called as half wave plate. Half wave plate. What is the first quarter wave plate function? It converts transmission of signal TE11 we will call to circular. Which shape? Circular shape it will convert, which is given here. The quarter wave plate converts linear polarized TE11 mode to which circularly polarized. Next, this off wave plate is producing the phase. Which is producing phase here? Off wave plate is producing the phase shift. After producing phase shift, what we have here? Here we have circular shape. Which shape we have? Circular shape only we have. Again, I am converting to another quarter plate. Then at that time, what happens? Input is TE11. Input is TE11. TE11 is applied to off quarter plate, which it is converting to which wave? Circular wave. Again, off wave. What is the function of off wave? It will change the phase. It will change the phase. Next, I am using another quarter wave plate. Now, for which purpose I am using another quarter wave plate? Another quarter wave plate is used to convert circular to TE1. So, your original wave is which one? Your original wave is TE1 only. I know. Original is TE11. At input, which wave I have? Original is TE11. This TE11, after passing to the quarter wavelet, what we are getting? We are getting circular. What is this will do? Just it will work on phase. It will work on which one? Phase. Next, what is the function of another? Now after phase, what is your input here? Circular only. Input is circular only. After passing with another quarter wavelet, what you will get here? Again, TE11. Both the sides, input side, output side, the wave is TE11 only. In between, it is converting to the circular, again circular to the TE11. This is given in this paragraph. In the previous introduction, what is given to this diagram? Description of the diagram. What is the description of the diagram is given here? The basic components of rotatory phase shift consist of two rectangular, two circular waveguides. Two rectangular, in between circular waveguide. It also consists of intermediate section of circular waveguide. In between what we have? Circular waveguide with two quarter wavelets. It has circular waveguide with off wave plate in between those. The description of the diagram is given. So if you get in the exam phase shifters, means you have to write which one? Rotatory phase shifter. Rotatory phase shifter, which if they ask about phase shifter. Next, what is the next topic we have? Faraday rotation and its application. Now we will see next one. Faraday rotation and its application. Here, which type of material we are using? Ferrite material. The very important point is we are using which material, ma? Ferrite material is used from input to output device. Ferrite material is used from input to output device. Now we will see the functioning of this Faraday rotation. Now we will see. Mm. Mm. Where we are using this one? Ferrite material have important application in microwave frequencies. It has important application in microwave frequency. A plane wave, which is TE11 wave. Is it? A plane linearly polarized wave is propagating in the medium and it is passing from ferrite material. In between what we have? Ferrite material. A plane wave is passing from input to output. It is passing from where? Ferrite material. It is passing from the ferrite material. A plane polarized wave propagates through the ferrite, which is subjected to DC magnetic field. Here we are applying magnetic field. Then the plane polarization wave is rotating across the ferrite material. This is called as Faraday rotation. This is called as Faraday rotation. Actually, we have input and output. Input and output. In the middle, what I have? Ferrite material. When it is propagating from input to output, when it is reached to the ferrite material, it is performing a rotation. That rotation is called as Faraday rotation. From input to output, when it is reached to the ferrite material, after applying magnetic field, it is rotating. That rotation is called as Faraday rotation. That is given in the first paragraph. And now next we will see the continuation. It has non-reciprocal effect. It has non-reciprocal effect. Here, what is the meaning is, when I applied magnetic field in the Z direction, just observe the diagram. Here, I am considering x-axis and y-axis with a component E0. With the component E0. This E0 is again one side showing clockwise direction, like this. Another side, anti-clockwise direction. Here, I am concentrating this one along Z-axis with like this, with small angle theta. The length here I am choosing as a L. L is the length. Now this derivation part we will see. What is given in the derivation part? At z equal to 0, E equal to x E naught. At z equal to 0, E equal to x E naught. Based on this, we will write expression E equal to x E naught. This one I am writing with real and imaginary terms. E is divided as E naught by 2 plus E naught by 2. What we will get? E naught only we will get. E naught. So that E naught I am writing as E naught by 2, E naught by 2 with real and imaginary terms. One term I am taking as x plus iy, x plus jy. Another term I am taking as a x minus jy. X E naught by 2, x plus jy, x minus jy times of E naught by 2. This one, again, I am writing in terms of phase constant, different phase constant. Here one phase constant is beta plus, another phase constant is beta minus. Now, just see the next change in this diagram. Same E naught by 2 we have. X plus jy. To this one, I attached e to the power of minus j beta minus L to the first term. To the second term, I attached e to the power of minus j beta plus L. Cross check whether plus is written or not. That is plus. Previous is e j b minus j beta minus L. This is j beta plus L. Next time, what I am doing? I am taking real terms one side, imaginary terms other side. I'll check what is E naught by 2 as it is written. Real term is which one? X. Real term is X. So, E power complete writing in terms of X. Next, imaginary term ki rasam. Same. ఒక టర్మ్ ఏమో రియల్ కి ఒక టర్మ్ ఏమో ఇమాజినరీకి ఈ రెండు రాసేసి నెక్స్ట్ రైటింగ్ దిస్ వన్ ఇన్ టర్మ్స్ ఆఫ్ కాస్ట్ రైటింగ్ దిస్ వన్ ఇన్ టర్మ్స్ ఆఫ్ కాస్ట్ మనకు ఒక ఫార్ములా ఉంటుంది కాస్ట్ ఈక్వల్ టు ఈ పవర్ ఎక్స్ ప్లస్ ఈ పవర్ మైనస్ ఎక్స్ బై 2 అని మ్యాథమెటిక్స్ లో ఈ పవర్ ఎక్స్ ప్లస్ ఈ పవర్ మైనస్ ఎక్స్ బై 2 ఆ బేస్ పైన అప్లై చేసి నెక్స్ట్ 7.4 ని తీసుకొచ్చినాం చూడండి ఇక్కడ ఏం చేంజ్ ఉంది ఎక్స్ ని లోపలికి మల్టిప్లై చేసిన ఈ పవర్ ఎక్స్ ప్లస్ ఈ పవర్ మైనస్ ఎక్స్ ఏం రాస్తున్నా కాస్ట్ రాస్తున్నాను ఈ పవర్ ఎక్స్ ప్లస్ ఈ పవర్ మైనస్ దీన్ని ఎల్ బై 2 చేసాం చూడండి ఈ ఈక్వేషన్ తీసుకొస్తున్నాం దీని నుంచి సో చూడండి ఈ ఈక్వేషన్ వచ్చినాక ఏం చేస్తున్నాము సేమ్ థింగ్ ని ఇన్ టర్మ్స్ ఆఫ్ కాస్ట్ లో మెన్షన్ చేస్తాం కాస్ట్ ఇటా ఇక్కడ సైన్ టీటా ఒక కాస్ట్ టర్మ్ ఇక్కడ సైన్ టర్మ్ లో రాస్తున్నాను రాసాక ఇక్కడ బీటా ప్లస్ బీటా మైనస్ బై ఎల్ బై 2 ఉందా బీటా ప్లస్ బీటా మైనస్ టైమ్స్ ఆఫ్ ఎల్ బై 2 దిస్ వన్ ఈజ్ టీటాలో రాస్తున్నాం సైన్ టాన్ టీటా అంటే సైన్ బై కాస్ కదా ఇన్ టర్మ్స్ ఆఫ్ టాన్ ఇన్వర్స్ లో రాస్తున్నాం సైన్ బై కాస్ రాసేసి ఓవర్ గా టీటాని ఈక్వేట్ చేస్తున్నాం దీన్ని బీటా ప్లస్ బీటా మైనస్ టైమ్స్ ఆఫ్ ఎల్ బై 2 ఉందా దిట్ ఈస్ ఈక్వల్ టు విచ్ వన్ టీటా 2 టీటా ఏమొస్తుంది minus of beta plus beta minus of times of L by 2. That is 2 theta. So this is the formula of Faraday rotation. This is the explanation of the Faraday rotation. Just we will recall what we discussed. Derivation part only. What is Faraday rotation? Transmission from input to output side. It is the middle. It is passing from the ferrite material. It is changing its direction and it is rotating after facing the ferrite material. Here I am considering z axis x y z. So I am taking along z direction with length L to this one. First I am taking E equal to x e naught. This x e naught I am writing in terms of plus and minus real complex conjugate form. Next to this one, I applied E and cos and finally I am bringing tan inverse. You have to practice these steps. And 2 theta what we will get? Minus of beta plus beta minus times of L. So up to here if you write, the answer is which one? Faraday rotation. The answer is Faraday rotation and its application. Next, see here. This Faraday rotation is work with three concepts. One is gyrator, another one isolator, another one is circulator. Now we will see the gyrator first one. Gyrator. Again to this gyrator, we have port 1, port 2, port 1 to port 2. When the wave is moving, it faces 180 degrees phase shift. When it is going from port 1 to port 2, we have 5/2 అంటే ఎంత 90. 5 అంటే 180. So when it is traveling from input port 1 to port 2, it is facing 180 degrees phase shift. But it is traveling from port 2 to port 1. It having 0 degrees phase shift. 0 degrees phase shift. Now we will see the first diagram, first paragraph. In this, what is explaining? Gyrator is a 2-port microwave device. It has relative phase difference is how much? 180 degrees when it is going from port 1 to port 2. However, for transmission from port 2 to port 1, there is a 0 degrees phase shift and the diagram is shown. Figure 7.3 is shown. Next, gyrator works on the principle of non-reciprocally property of Faraday rotation. Even in the Faraday rotation also we mentioned one formula that it is a non-reciprocal effect. Okay, non-reciprocal effect it is working. And the main parts here, just observe the diagram down. What are the main parts of this gyrator? Looks bigger, but concept is very easy. And see this diagram. What you have? Two ends you have. First, I will explain the diagram. Next, we will see paragraphs. Input undi, output undi. From input to the middle part, there is a twist. Twist ante enti itla undi anukondi. Twist chestunnam. Rotate chestunnam direction. Next, it will face ferrite material. Ferrite material. Oka bar laga undi, dash lines unnai kada. This is ferrite material. What is this one? Ferrite material. Em material idi? Ferrite material. So first signal ఇక్కడ వస్తుంది, ట్విస్ట్ టచ్ అవుతుంది అంటే 90 degrees అవుతుంది. నెక్స్ట్ ఫెర్రైట్ మెటీరియల్ పాస్ అవుతుంది, మళ్ళీ ఏమొస్తుంది ఇంకా 90 degrees యాడ్ అవుతుంది. టోటల్ ఎంత వచ్చింది అవుట్పుట్ కి వచ్చే వరకు 180 degrees ఫేజ్ షిఫ్ట్ ఉంది. ఈ ఫిగర్ నంబర్ 7.5 చూడండి. ఫిగర్ నంబర్ 7.5 చూడండి. ఫస్ట్ ఇన్పుట్ వేవ్ ఇచ్చాం, ట్విస్ట్ ఎంత తీసుకుంటుంది? 90 తీసుకుంటుంది. మళ్ళీ ఫెర్రైట్ కి అటాచ్ అయినప్పుడు ఇంకొక 90 తీసుకుంటుంది. టోటల్ ఎంత అయింది? 180. సో 180 అంటే ఇన్పుట్ అప్వర్డ్ లో ఉంటే అవుట్పుట్ కి వచ్చే వరకు డౌన్వర్డ్ డైరెక్షన్ అయింది. ఈ 180 ఎక్కడి నుంచి వస్తుంది? ఒకటి ట్విస్టర్ నుంచి, ఇంకొకటి మ్యాగ్నెటిక్ ఫీల్డ్ నుంచి. ఈ రెండు అప్లై అయ్యి మనకు 180 degrees ఫేజ్ షిఫ్ట్ వచ్చింది. దట్ ఈస్ ఎక్కడి నుంచి? ఇన్పుట్ నుంచి అవుట్పుట్ కి, విచ్ ఈస్ గివెన్ హియర్. సి 5 radians అని ఇచ్చారు కదా. ఇన్పుట్ నుంచి అవుట్పుట్ కి వెళ్ళేటప్పుడు మనకు 180 degrees ఉంది. నౌ వి విల్ సి అవుట్పుట్ టు ఇన్పుట్ ఎంత ఉండాలి? ఫేజ్ యాంగిల్ 0 ఉండాలి. వి విల్ సీ హౌ వి ఆర్ గెటింగ్. బ్యాక్వర్డ్ వెళ్ళండి. ఇప్పుడు మన సిగ్నల్ డౌన్వర్డ్స్ ఉందా, అప్వర్డ్స్ ఉందా? డౌన్వర్డ్స్ ఉంది. ఇక్కడ ఈ పారాగ్రాఫ్ చూడండి, సెకండ్ పారాగ్రాఫ్. వేవ్ ప్రాపగేటింగ్ ఫ్రమ్ రైట్ టు ద లెఫ్ట్, port 2 నుంచి port 1 కి వెళ్తుంది. ద ఫారడే రొటేషన్ 90 degrees ఇన్ సేమ్ డైరెక్షన్. అట్లనే 90 degrees సేమ్ డైరెక్షన్ లో ఉంది. నెక్స్ట్, బట్ ఇన్ పాసెస్ త్రూ ద ట్విస్ట్ యాంగిల్ ఆఫ్ రొటేషన్ 90 degrees ఇన్ క్లాక్ వైజ్ డైరెక్షన్ లో ఉంటుంది. అంటే ఒకటి క్లాక్ వైజ్ డైరెక్షన్, ఒకటి యాంటీ క్లాక్ వైజ్ డైరెక్షన్, రెండు క్యాన్సల్ అయిపోతుంది. క్లాక్ అండ్ యాంటీ క్లాక్ వైజ్ క్యాన్సల్ అయిపోయి 0 degrees ఫేజ్ షిఫ్ట్ వస్తుంది. ఇక్కడేమో రెండు సేమ్ యాంగిల్స్, సేమ్ రెండు క్లాక్ లోనే ఉన్నాయి. అదే రెండు క్లాక్ లో ఉన్నాయని చెప్పొచ్చు, రెండు యాంటీ క్లాక్ లో సేమ్ డైరెక్షన్ లో ఉన్నాయి. అంటే ఏంది? మన ఇన్పుట్ వేవ్ ఇట్లా వస్తుంది, ఇట్లా వచ్చింది, దీనికి 90 degrees షిఫ్ట్ అయింది. 90 అంటే ఇట్లున్నది, ఇట్లా వస్తుంది. ఇంకొక 90 వస్తే డౌన్వర్డ్ అయిపోయింది. కానీ అవుట్పుట్ కి ఏమైతుంది? ఆల్రెడీ డౌన్ లో ఉంది. ఫెర్రైట్ మెటీరియల్ 90 degrees యాంటీ క్లాక్ వైజ్ లో ఉంది. ట్విస్టర్ ఏమిస్తుంది? ఇంకొక 90 degrees ఇస్తుంది, కానీ ఏ డైరెక్షన్ లో? క్లాక్ వైజ్ డైరెక్షన్ లో ఇస్తుంది. ఒక యాంటీ, ఒక క్లాక్, రెండు క్యాన్సల్ అయిపోయి మనకు అవుట్పుట్ అనేది 0 వస్తుంది. మీరు 3 diagrams రాస్తే ఎక్స్ప్లెయిన్ చేస్తే వితౌట్ డెరివేషన్ పార్ట్ యూ స్కోర్ మ్యాథ్స్ ఈజీలీ టు దిస్ గైరేటర్. ఇప్పుడు పారాగ్రాఫ్ చూద్దాం ఏమి ఇచ్చాడు చూడండి. ఫస్ట్ పారాగ్రాఫ్ అయిపోయిందా చూద్దాం. ఏ గైరేటర్ ఇస్ వర్కింగ్ ఆన్ ద ప్రిన్సిపల్ ఆఫ్ నాన్ రెసిప్రోకలీ ప్రాపర్టీ. ఆల్వేస్ రిమెంబర్, ఇన్పుట్ నుంచి అవుట్పుట్ కి ఎంత వస్తుంది ఫేజ్ 180 వస్తుంది. అవుట్పుట్ నుంచి ఇన్పుట్ కి ఎంత వస్తుంది ఫేజ్ 0 degrees వస్తుంది. On the principle of non-reciprocal properties of Faraday rotation, a gyrator description is given in this paragraph. The main parts of the gyrator. What are the parts we have? Two side circular with twist. Twist two sides ఉందా, సింగిల్ సైడ్ ఉందా? ఓన్లీ వన్ సైడ్ ట్విస్ట్ ఉంది ఇక్కడ. ఇంత మధ్యలో ఏముంది మనకి? ఫెర్రైట్ మెటీరియల్ ఉంది. See here. The main parts of the gyrator is rectangular waveguide section at the ends. The gyrator consists of one gyrator is connected with another gyrator using the twist. Okay, the twist is connected only at the first side. In the middle, what we have? In the middle, we have ferrite rod, and I am applying which field? Magnetic field. After applying the magnetic field, what happening? We will see the next paragraph. Ferrite material, how much angle it is producing? 90 degrees. Twister is producing 90 degrees. Total 180 degrees in the same direction. ఇక్కడ చూడండి. ఈ paragraph 180 degrees produce. So from port 1 to port 2, how much phase angle it is producing? 180 degrees phase angle is produced from port 1 to port 2. This diagram is given in 7.5. Port 1 to port 2, 180 degrees phase shift. Now we will see port 2 to port 1. ఎంత వస్తుంది? 0 ఎందుకు వస్తుంది? Faraday rotation. Sorry, this ferrite material 90 degrees in anti-clockwise direction. Twist is clockwise direction. Anti and clock both will be cancelled. Output is in 0. Output is 0. This is about the gyrator. Just go through once. If it is clear, I will go to the next one. 3 diagrams. Easier only this one compared to previous. And next we will see isolator. What you are understood from 7.7 diagram? Diagram 7.7. In 7.3, port 1 to port 2, 180 degrees. Port 2 to port 1, 0 degrees. Same way, compare this one. Input to output going, no attenuation. No attenuation from input to output. But output to input? Attenuation. Output to input, is attenuation there or no? What is the meaning of attenuation? Attenuation means gradual reduction in the strength of the signal beam. When signal beam is reducing. Signal beam is reducing. This is input signal, but it comes to the output, what happening? Signal strength is decreased. And now you see, ante no attenuation ante meaning enti? Input signal, whatever is there, the same signal is coming across output. No attenuation. No signal is decreasing. Signal strength is not decreased. Whatever you have across the input, same thing you are getting across output. But you are going from output to input side. There is a attenuation. Output to input, there is a attenuation. Now we will see the first paragraph. What is given in the page number 70? It is a two-port. It is a two-port microwave device. It allows unattenuated transmission from port 1 to port 2, but very high attenuation transmission is giving in reverse direction. And coming to the reverse direction, very high attenuation is produced. Next, using this isolator, there is a mismatch, avoiding the mismatch. It avoids mismatch between input and output. This avoids any mismatch between the source and load. This is the important point enough up to here. And next come to the diagram. After 7.7 diagram, we have which figure? Figure 7.8. What is the difference between 7.8 diagram, 7.4 diagram? Anyone? What is the difference between the 7.8? Here, resistive. A clear image I will show with clear image I will share of this one. We are discussing isolator, is it? This is the diagram of isolator. This is the diagram of isolator. Internal, what it is. See here, input waveguide. A plain input wave I am applying. Input waveguide. To this input waveguide, here, no marker. Input waveguide. To this wave, input wave. Two sides I am connecting resistive vanes. Two resistive vanes are kept across input and output side. Two resistive vanes are connected. Again, in the middle, we have ferrite material. What we have? Ferrite rod is there in the middle. And now, this, see here, I am applying input. I am applying input. Again, what happening? It is going to the reflected wave. Where it is going? It is going to the reflected wave. This reflected wave is producing 45 degrees. Again, this is producing 45. Total is 90 degrees phase shift. Input to output is 90 degrees phase shift. This one we will see in the P textbook what it is mentioned. We'll see isolated description first. You saw the diagram? Now we will see isolated description. The construction of isolator is similar to gyrator. There it is produced 90 degrees phase shift. Here it is producing 45 degrees phase shift. 45 degrees twist section and 45 degrees Faraday torsion. So this magnetic material is producing 45 degrees. This twist is producing 45. Total is 90 degrees. అక్కడ ఏమొచ్చింది మనకి 90 plus 90 180 వచ్చింది. ఇక్కడ 45 plus 45 90 వస్తుంది. అదొకటే మెయిన్ డిఫరెన్స్. Thin resistive cards are inserted across input and output waveguides. Across input side, output side, thin resistive cards are inserted. What is the use of these cards? These cards are used to observe the field that is polarized with electric parallel to the walls of the rectangular section. It is parallel to the walls. These are parallel to the walls. Next. The ferrite rod is producing how much phase shift? The ferrite rod is producing 45 degrees of rotation. Next. See the waveform here. I am given input to. Next, this resistive winds is producing how much? 45 degrees. 45 degrees. Next, 45 degrees by ferrite material. But one is in clockwise direction, another one is in anti-clockwise direction. So both will cancel with each other. This is 45 degrees like. This is 45 degrees like. Okay. Clock and anti-clock both will cancel. One is anti-clock, another one is in clockwise direction. So both are cancelling. Whatever the wave you are giving across the input, the same wave is appeared across the output. When it's going from port 1 to port 2, going from input to output, 0 degrees phase shift, which is given below the figure number 7.9. What is written here? A wave propagating from port 1 to port 2 has its plane polarization of 45 degrees in anti-clockwise direction by the twist. Twist అంటే వీన్. దీని నుంచి ఎంత వస్తుంది? 45 degrees in anti-clockwise లో వస్తుంది. ఇది ఫెర్రైట్ రాడ్ నుంచి 45 degrees in clockwise direction లో వస్తుంది. ఇది ఒక 45 ఇస్తుంది. Above diagram. ఈ రెసిస్టివ్ వెయిన్ ఒక 45 degrees ఇస్తుంది. ఇది ఇంకొక 45 degrees ఇస్తుంది. వాట్ ఎవర్ ద 45 దిస్ ఈస్ గివింగ్, దిస్ ఈస్ ఇన్ యాంటీ క్లాక్ వైజ్ డైరెక్షన్. వాట్ ఎవర్ 45 is produced, this is in clockwise direction. These two will cancel each other. So the output is of same phase. Output is of same phase. This is transmission from port 1 to port 2. Now we will see transmission from port 2 to port 1. Reverse direction లో చూడాలి. ట్రాన్స్మిషన్ ఫ్రమ్ పోర్ట్ టు. నౌ ఇప్పుడు 2 figures ఇచ్చారు మనకు. ఫిగర్ 7.9 కి ఫిగర్ 7.10 కి ఏంటి డిఫరెన్స్ చెప్పాలి. ఫిగర్ 7.9 చూసి చెప్పాడు. 7.9 అయిపోయింది కదా. 7.10 what is given in 7.10. However, a wave is propagating from port 2 to port 1, 45 degrees clockwise direction by ferrite rod and 45 degrees clockwise direction by twist selection. So it is 90 degrees total difference. This one, both comparison I will show you because very important to remember for the examination. చిన్న స్మాల్ డిఫరెన్స్ తెలిస్తే మీరు ఎగ్జామ్ లో దీన్ని ఎలాబొరేట్ చేసి రాయొచ్చు. ఫస్ట్ చెప్పండి. ఇది గైరేటర్. ఫస్ట్ వి విల్ రైట్ గైరేటర్. గైరేటర్ ఏమవుతుంది? ఉంది ఇక్కడ మనకు ట్విస్ట్ ఉంది. ఈ ట్విస్ట్ ఎంత ఇస్తుంది? 90 degrees. నెక్స్ట్ ఇక్కడ ఫెర్రైట్ రాడ్ ఉంది. దిస్ ఫెర్రైట్ రాడ్ is giving 90 degrees. While coming to the output, it is 180 degrees. This is from port 1 to port 2. Port 1 to port 2. Now, the same we will see from port 2 to port 1. చెప్పండి. Port 2 to port 1. Ferrite rod 90 degrees in anti. Ferrite rod 90 degrees in anti. Next. నెక్స్ట్ 90 degrees యాంటీ. నెక్స్ట్ ఇక్కడ 90 degrees ఫెర్రైట్ రాడ్ వస్తుంది. ఇక్కడ ఎక్కడ నుంచి ఇది? పోర్ట్ 2 నుంచి. దిస్ ఇస్ ఫ్రమ్ పోర్ట్ 2. ఇక్కడ ట్విస్టర్ 90 ఇస్తుంది. 190 is anti, another one is clockwise. So clock and anti-clockwise cancelled, and whatever the is there, same thing you are getting. You are getting same thing. This is about gyrator. So gyrator లో ఒకటి 180 వస్తుంది. పోర్ట్ 1 నుంచి పోర్ట్ 2 180 వస్తుంది. రివర్స్ ఏమొస్తుంది? 0 వచ్చేది. This is about gyrator. And next one ఏం చూడాలి? Isolator. Now we will see isolator. Isolator. Diagram of isolator చెప్పండి. ట్విస్టర్ 45 ఇస్తుంది. ఫెర్రైట్ మెటీరియల్ 45 ఇస్తుంది. Total 90. వస్తుందా? Cancel with each other. One is clock, one is anti-clock. Port 1 నుంచి port 2 కి. We are writing from port 1 నుంచి ఎక్కడికి? అదే ఇంపార్టెంట్ పాయింట్స్ ఇందులో. Port 1 నుంచి port 2 కి ట్విస్టర్ 45 ఇస్తుంది. ఫెర్రైట్ 45 ఇస్తుంది. బట్ దిస్ ఈజ్ ఇన్ యాంటీ క్లాక్ ఒకటి, క్లాక్ ఒకటి, యాంటీ క్లాక్ ఒకటి, క్లాక్ ఒకటి. సో పోర్ట్ 1 నుంచి పోర్ట్ 2 కి ఏంది? 0. పోర్ట్ 1 నుంచి పోర్ట్ 2 కి 0. నెక్స్ట్ పోర్ట్ 2 టు పోర్ట్ 1 90 వస్తుంది. I will write final conclusion instead of this. ఇప్పుడు చెప్పండి. గైరేటర్. ఫస్ట్ వన్ ఇస్ గైరేటర్. పోర్ట్ 1 నుంచి పోర్ట్ 2 కి ఎంత ఇస్తుంది? 180 degrees ఫేజ్ షిఫ్ట్ ఇస్తుంది. 180 degrees ఫేజ్ షిఫ్ట్. నెక్స్ట్ పోర్ట్ 2 టు పోర్ట్ 1 0 degrees ఫేజ్ షిఫ్ట్ ఇస్తుంది. మనకి పాయింట్స్ ఎగ్జామ్ లో గుర్తుంటే మనం రాయొచ్చు. నెక్స్ట్ కమ్ టు ఐసోలేటర్. పోర్ట్ 1 టు పోర్ట్ 2 45 రెండు ప్రొడ్యూస్ చేస్తుంది. ఈ రెండు 45 ఏమవుతున్నాయి? క్యాన్సల్ విత్ ఈచ్ అదర్ అయి పోర్ట్ 1 టు పోర్ట్ 2 మనకు 0 degrees వస్తుంది. నెక్స్ట్ పోర్ట్ 2 టు పోర్ట్ 1 రెండు క్లాక్ వైజ్ డైరెక్షన్ లోనే ఉండి ఒకటి 45 ఇంకొకటి 45 రెండు ఎంత కలుపుతుంది? 90 degrees వస్తుంది. సో దిస్ ఆర్ ద కీ కాన్సెప్ట్స్. మీరు గుర్తుపెట్టుకోవాలి. ఫస్ట్ లోనేమో 180 రిటర్న్ 0, ఇక్కడనేమో 0 90 degrees, 0 90 degrees. So this is the diagram of isolator. These are the diagrams of gyrator. For exam point, very important diagrams and explanation part, essay questions. And next one more we have. The last one is in this chapter is circulator. We will see next circulator. Next is circulator. Circulator. In circulator, how many? Just observe the figure 7.11. Circulator having 4 ports. How many ports more? 4 ports. Port 1 is connected to port 2. Port 2 is connected to port 3. Port 3 is connected to port 4. Port 4 is connected to port 5. Like we can imagine that n ports are there. Suppose port 1 is input. Port 1 is input. At that time, port 2 is output. If port 2 is in, port 3 is output. If port 3 is in, port 4 is output. If port 4 is input, this is port 1 is out. So if nth port is acts as input, which port? Nth port is acts as input, n plus 1 port acts as a output, which is given in the first paragraph. Which is given in the first paragraph. What is given in the first? A circulator as a passive microwave multi-port device. A wave incidenting on port 1 is coupled to only port 2. A wave incidenting at port 2 coupled to port 3. A wave incidenting at port 3 coupled at port 4 only. So if n ports are coupling, its output is across n plus 1th port. The diagram is shown in the figure. This is mainly used as a duplexer in radar systems. Radar system lo is circulator ni duplexer laga use chestam. Next, how it is constructed. To construct this circulator, I am using 2 magic teas. Which magic tea where we discussed in second unit? Page number, just go back and check. మ్యాజిక్ టీ ఎక్కడ యూజ్ చేస్తామో సెకండ్ యూనిట్ లో, సెకండ్ బ్లాక్ లో పేజ్ నెంబర్ 55 చెక్ చేయండి. There we have magic tea. E plane, H plane, T తర్వాత మ్యాజిక్ టీ వస్తుంది. ఇట్ ఇస్ ద కాంబినేషన్ ఆఫ్ ఈ ప్లేన్ అండ్ హెచ్ ప్లేన్. పేజ్ నెంబర్ 56 లో, పేజ్ నెంబర్ 56 లో magic tea. So here we are connecting two magic teas. Another diagram, clarity diagram. I will show that one. Circular diagram. This is the circle. So here how many magic teas is connected? Two magic teas is connected. When a wave is incidenting on port 1, it will come across port 2. A wave is incidenting on port 1 will come across port 2. Explanation. This is this. So it is a combination of how many magic teas? Two magic teas. One side magic tea connected this side, another magic tea is connected this side, and with one gyrator. Another one is one gyrator. This gyrator how is connected of pi or pi by 2? Pi, 180 degrees phase shift. This gyrator is producing 180 degrees phase shift. See, this gyrator is producing 180 degrees phase shift in downward direction. Oh no? In downward direction, it is producing 180 degrees phase shift. In upward direction, it will produce 0 degrees phase shift. Upward direction of 0 degrees. Just check this diagram. 180 degrees phase shift in downward and 0 degrees phase shift in the upward direction. Total, like this it is showing. Next we will see explanation part with this topic. See here, a wave is incidenting on port 1. It is splitting into two equal phases, in phases. A wave is shifting, a wave is sending at port 1. The output of the wave is coming at port 2. A wave is inserting at port 1. Output wave is coming across port 2 with 0 degrees phase shift. 0 degrees phase shift. Like this. A wave is inserted. See the how many paragraphs? Here 3 paragraphs is mentioned. A wave is incidenting on port 1. This is splitting into two equal magnitude in phases. So, how much phase shift is giving? 0 degrees phase shift. And this wave is emerging across port 2. This wave is emerging across port 2. Wave is splitting across input port. Two equal waves it is dividing. And it is producing how much phase shift? 0 degrees phase shift. And where the wave is appeared? The wave is appeared across port 2. Now take second one. A wave is incidenting across port 2. A wave is incidenting across where? Port 2. Where it is coming? It is coming to port 3. This one. A wave is incident port 1, it will come to 2. If it incidents on 2, it will come to 3. If it is incidenting on 3, it will come to 4. Now you check 180 degrees phase shift or 0 degrees phase shift. I want that one. A wave incidenting on port 2, it is going to port 3. It is producing 180 degrees phase shift. Means it is traveling in downward direction. It is traveling in downward direction. Understood? Suppose if the wave is incident on port 3. Image. A wave is incidenting on port 1. It is traveling to port 1 in upward direction. So angle is 0. A wave is incidenting on 2. It has to pass ఎక్కడికి పాస్ అవ్వాలి 3కి. అప్ నుంచి వెళ్తుందా డౌన్ నుంచి వెళ్తుంది ఇట్లా వచ్చి ఇట్లా వెళ్తుంది అంటే 180 degrees ఫేజ్ షిఫ్ట్ వచ్చేసింది. ఇప్పుడు చూడండి ఏ వేవ్ పాసింగ్ ఎట్ పోర్ట్ 3. ఇట్ హ్యాస్ టు రీచ్ 4 డిసైడే ఉంది ఫార్వర్డ్ డైరెక్షన్ లో ఉంది కదా యాంగిల్ ఎంత 0 degrees వస్తుంది. అర్థమైందా? ఆ వేవ్ 4 లో ఉంది 1 లోకి రావాలి 180 degrees వస్తుంది. Now I will show this one in board. This is circulator. మనకి ఇట్లా ఉన్నాయి ఇక్కడ ఇటు సైడ్ ఏమేమి ఉంది 1 3 ఉంది ఒక సైడ్. ఇక్కడ ఒకటి ఉంది హియర్ ఇంకొకటి ఉంది. ఇక్కడ ఎంత ఉంది 180 degrees, here 0 degrees. What are the things we have here? Port 1, port 3. This side we have 2, 4. I want to travel from 1 to 2. Different colors have it is 1 to 2. It is passed from 0 or 180. It is passed from 0. So phase shift is 0. Phase shift is 0. I want to travel from 2 to 3. 2 to 3 వెళ్ళాలి ఎంత 2 to 3 అంటే 180 degrees. I want to travel from 3 to 4. పైనుంచి వెళ్తుందా కింద నుంచి వెళ్తుందా పైనుంచి వెళ్తుంది ఫార్వర్డ్ డైరెక్షన్ 3 to 4. So what is the phase angle? 0 degrees. I want to travel from 4 to 1. It has phase shift of 180. This is given in explained in 4 passages. This is explained in 4 passages. See here, what is given in the first passage? A port 1 is splitting into 2 equal magnitudes. It has to reach to where? Port 2. It is phase angle 0. And next see, input is incidenting across port 2. It has to reach to the port 3 with phase angle 180 degrees. Next input is across port 3. It has to reach port 4. It is taking 180 degrees phase angle. Like different phase angles is mentioned from input to output. After that, we have to mention that how many magic teas? 2 magic teas with 1 gyrator. Total it is acts as a circulator. In this examination diagram is very easy. How to remember diagram? Here you have port 1, here you have port 2, here you have port 3, here you have port 2. Port 1 నుంచి port 2 కి వస్తుంది 2 నుంచి 3 నుంచి 4 కి 4 నుంచి 1 కి ఇక్కడ ఈచ్ పోర్ట్ కి వెళ్ళేటప్పుడు 0 degrees ఉందా 180 degrees ఉందా మెన్షన్ చేయాలి. నెక్స్ట్ నాకు సో 4 పోర్ట్స్ ఉన్నాయి. ఇంకోటి గైరేటర్ ఎంత ఉంది 180 degrees gyrator ఉంది 180 degrees phase shift ఉంది. For this I am using conditions. What are the conditions? S11, S1, S22, S33, S44. ఇవన్నీ 0 పెట్టేస్తున్నా. Next I am writing final scattering matrix. What is the final scattering matrix? S equal to 0 0 0 1. Explain చేసాక matrix రాయాలి 0 0 0 1. Next 1 0 0. Next 0 1 0 0. Next 0 0 1 0. Remember that diagonals are zeros. Remember that diagonals are zeros. This is about circulator. Now we will see which type of model questions we will get from this one. And which page how to write. What, first is 7th question. What are the applications of gyrator, isolator, circulator? ఎక్కడ ఉంది అది అన్నిట్లలో కింద మీకు అప్లికేషన్స్ రాశారు చూడండి ప్రతి ఒక్క టాపిక్ లో అప్లికేషన్స్ రాశారు. సో అన్ని సెట్స్ ఒక దగ్గర రాసుకొని నోట్స్ చేయాలి. ఓన్లీ అప్లికేషన్స్. ఇంకొకటి Construction and working of 4-port circulator. Construction and working on 7.33. ఎంతమ్మా 7.33 లో ఓన్లీ సర్క్యులేటర్ గురించి రాయాలి. నెక్స్ట్ క్వశ్చన్, డిస్క్రైబ్ ద కన్స్ట్రక్షన్ అండ్ వర్కింగ్ ఆఫ్ ఐసోలేటర్. అంటే ఏమొస్తుంది 45 రెండు క్యాన్సల్ అయిపోయి 0 వస్తుంది. రివర్స్ తో 45 90 డిగ్రీస్ వస్తుంది. డయాగ్రామ్స్ వేయాలి. దట్ ఈస్ ఐసోలేటర్. నెక్స్ట్ వన్ గైరేటర్. గైరేటర్ అంటే ఏం రాయాలి 90 90 180. రిటర్న్ ఇస్ క్లాక్ క్యాన్సల్ అయిపోయి 0 డిగ్రీస్ వస్తుంది. నెక్స్ట్ వన్ express derive an expression for the angle of rotation. Angle of rotation theta formula ఏంటి minus of beta plus minus beta minus by L by 2. Cross multiply చేస్తే 2 theta equal to minus of beta plus minus beta minus వస్తుంది. And theta in terms of tan లో కూడా రాయాలి. What is in terms of tan? Tan inverse of beta plus minus beta minus by cos of beta plus minus beta minus times of L by 2. Total tan inverse. ఏం చేస్తాం, ఈ కాంపోనెంట్ ఇస్ టేకింగ్ అలాంగ్ z డైరెక్షన్ అని చెప్పేసి ఈ డెరివేషన్ పార్ట్ చేయాలి. నెక్స్ట్, వాట్ ఈస్ ఫారడే రొటేషన్ అండ్ ఎక్స్ప్లెయిన్. ఇదే వస్తుంది ఫారడే రొటేషన్ అండ్ అప్లికేషన్. వాట్ ఈస్ ఫారడే రొటేషన్ అన్న సేమ్ ఆన్సర్ రాయాలి. 7.3 రాయాలి దానికి కూడా. నెక్స్ట్, ఎక్స్ప్లెయిన్ ద కన్స్ట్రక్షనల్ అండ్ వర్కింగ్ ఆఫ్ రోటరీ ఫేజ్ షిఫ్టర్. రోటరీ ఫేజ్ షిఫ్టర్ లో ఏం చదివినామమ్మా? రోటరీ ఫేజ్ షిఫ్టర్ ఏం చదివినా చెప్పండి. కార్నర్ లో 2 రెక్టాంగులర్ వేవ్ గైడ్స్ ఉంటాయి, 2 క్వార్టర్ వేవ్ ప్లేట్స్ ఉంటాయి, మధ్యలో హాఫ్ వేవ్ ప్లేట్ ఉంటుంది. ఈ ఫస్ట్ క్వార్టర్ వేవ్ ప్లేట్ ఏం చేస్తుంది, టీ నార్మల్ పోలరైజ్డ్ వేవ్ ని సర్క్యులర్ పోలరైజ్ కి కన్వర్ట్ చేస్తుంది. ఇక్కడ ఫేజ్ షిఫ్ట్ చేస్తుంది. మళ్ళీ ఇక్కడ ఉన్న సర్క్యులర్ ని నార్మల్ కి కన్వర్ట్ చేస్తుంది. దిస్ ఈస్ అబౌట్ రోటరీ షిఫ్టర్. Okay, this is about, so we completed today block 3, unit 6, unit 7. If you prepare this one, you will attempt one essay question and one short pattern from this block. Today's class completed. We'll see in the next class.